One of the biggest challenges in modern astronomy is not necessarily the lack of data, but it's actually having too much data. And that's because over the last 35 years, the Hubble Space Telescope, and actually a lot of other telescopes, have been collecting huge amounts of data in the night skies, producing a treasure trove of images that stretch back to the early universe. But that by itself created a bit of a problem. Today there are thousands and thousands of different datasets and nearly 100 million individual image cutouts just from the Hubble itself. This is known as the Hubble Legacy Archive, and even though some of these images have been collected decades ago, quite a few of them have never been examined. And so if a human astronomer tried to look at every single one of them, especially if they wanted to find something unusual, something strange, and something we've never seen before, it would take that one person multiple lifetimes to just briefly look at them, one after another. But today we're going to be discussing a very intriguing breakthrough from a team at the European Space Agency. And specifically here we have a really good example of a good AI use with this new AI tool that was able to sift through these hundreds of millions of images in just 2.5 days. And in that tiny window of time, it was able to identify approximately 1,400 objects that seemed a little bit anomalous and somewhat intriguing. But importantly, at least 800 of them have never been seen before. And so, hello wonderful person, this is Anton. In this video, let's discuss exactly how they did this and what was discovered, and also discuss why these anomalous objects are actually kind of important. And, well, maybe let's start with that. Why do we need to find these anomalies, and what exactly is this study even for? Well, here the story actually starts back in the 60s, and specifically in 1966. Back then, an astronomer by the name of Halton Arp realized that there's actually a lot of importance in studying bizarre objects, and not just regular galaxies and regular galactic clusters. And that's because he believed many of these strange shapes, such as this one, known as antenna galaxies, represent very bizarre experiments provided by the nature itself. And so by studying many of these anomalous galaxies, and by trying to figure out why they acquire these shapes, we can then learn about various physical processes that are usually invisible to us, and of course start making conclusions about mysterious dark matter, or possibly some other anomalies and other physical effects we never knew existed. For example, the effects from the gas behaving at extreme pressures, or how galaxies collide and what shapes they tend to produce. And so quite a lot of galaxies you're looking at here, for example these mice galaxies, actually have an additional designation from the Atlas of Peculiar Galaxies. This is known as ARP 242. And so yeah, Halton Arp basically decided to name a lot of these galaxies after himself by creating what's known as the Atlas of Peculiar Galaxies, with the atlas containing 338 unusual looking shapes, aiming to provide best examples of really bizarre galaxies in nature. Although ironically, he actually used his catalog and his observations to try to challenge the Big Bang Theory, specifically arguing that high redshift quasars were physically connected to low redshift galaxies and were not as far away as claimed. But a lot of his observations and a lot of additional observations basically proved them incorrect. Although despite this controversy, this atlas remains a significant creation, especially for studying different anomalies. And so because of him, a lot of scientists realized that many of these anomalous shapes represent a very specific part of a galactic life that's usually extremely rare and very difficult to capture. For example, this right here. A specific merger or a specific interaction that then produces rings that are going to disappear in near future. And so these particular events are very hard to catch, mostly because they don't last very long. And so the point of this AI search was to try to increase the sample of these objects and to try to find these captured moments in additional objects we've never seen before. And once again, the main point is to try to understand some of these most extreme conditions and very unusual interactions. But to do this, the scientists behind the study had to create an entirely new tool. This is known as Anomalymatch. And so here David Orion and Pablo Gomez created this new framework that was a little bit different from what scientists used before. Now usually in most AI-based studies, or I guess to be more exact, in studies using machine learning or neural networks, most models are usually supervised. Basically, you tell the computer exactly what a spiral galaxy looks like, and it tries to find more of them, classifying them extremely quickly. But by definition, anomalies are difficult to classify. They are things we don't expect. And so if you don't really know what you're looking for, how can you train the computer to do any of it? And well, this is why Anomalymatch uses what we refer to as semi-supervised active learning. Basically, it's a kind of a collaboration. Here, the neural network looks for a few examples of normal galaxies and a very small number of anomalies. And it then starts scanning millions of unlabeled images and picks out the ones that it thinks are the most unusual. So in essence, the images acquire what's known as the anomaly score. It then presents these images to the human expert through a custom-made user interface. And this is where the person then says, okay, this is a real discovery, or no, this is just a camera glitch. And so based on this feedback, the neural network gets better and better with every cycle, and the person has to do less and less. And this human-in-the-loop approach is powerful because here humans are still just a little bit better at knowing when something is a true anomaly and not just a statistical error. And that's exactly what the scientists in this study did, turning this AI into a power tool that then was able to scan 100 million individual images in just under 72 hours, with the results being quite spectacular. And so what exactly did they find? And once again, they discovered approximately 1400 different objects, and researchers personally verified them to make sure these were not just artifacts. And all of them fell under one of 5 specific categories. First, the obvious one, galactic mergers and various types of tidal tails. This is of course one of the most common anomalies in the Atlas of Peculiar Galaxies as well, and so discovering so many of them was not unusual. And so here we had at least 2 galaxies that get really close, and the gravity starts to pull each of them apart, creating additional shapes such as tidal tails, made out of streams of stars and gas. And these are of course crucial because they generally show us exactly how galaxies evolve over billions and billions of years. Here's one example that was provided with the study, with the second example being just a little bit more unusual. It's not entirely clear what's actually happening in this collision. Which actually brings us to the next type of objects, gravitational lensing. And this is of course based on Einsteinian theories. Massive objects can actually bend the fabric of space, creating peculiar shapes and very distorted images if there is a lot of mass present between us and the light behind this object. And so if a massive galaxy sits directly in front of a more distant one, the gravity will act like a magnifying glass, warping the light from the background galaxy. And in this case, the AI discovered quite a few new examples, 140 to be exact. Then, the next type was the so-called jellyfish galaxies. And these are quite spectacular because, in this case, imagine a galaxy falling into a massive cluster of other galaxies, but as it moves through this region and interacts with the gas between galaxies, its own gas gets stripped away, creating these very bizarre long tentacles that make it resemble a jellyfish. And this is something that's been seen quite a few times, and basically is the result of a process referred to as RAM pressure stripping. It's actually one of the main ways a lot of galaxies eventually stop forming stars and basically become dead galaxies. And so here a lot of gas essentially gets stripped because of the interaction with additional gas as the galaxy moves through space. 35 such objects have been discovered. But then we have another class of galaxies that's actually really rare but super beautiful. Collisional ring galaxies. Here's one example that was provided in a study. And these usually form when a smaller galaxy somehow punches through a center of a larger galaxy that's usually disc-shaped, kind of resembling a pebble falling into a pond. And this results in a lot of shockwaves traveling outward, creating a bright ring of new stars that sometimes resembles something like this. This is the famous Cartwheel galaxy. Here, surprisingly, the AI only discovered 2. In essence, confirming how extremely rare these usually are. Now it actually discovered 12 ring galaxies, but they were not formed by collisions. Additionally, the team also discovered objects within our own galaxy as well, and pretty much all of these were protoplanetary disks, or basically young stars surrounded by disks of dust and gas, where the planets are currently forming. And we've actually discussed one of these such unusual objects in one of the recent videos in the description, but essentially many of them resemble hamburgers. So usually they resemble something like this. But naturally there were also examples of objects that did contain a high anomaly score, but the scientists were unable to morphologically classify. Or I guess just to rephrase this, they discovered some objects that we don't really understand. These could be galaxies, and some of them do resemble galaxies, but it's not clear what's happening in this image. But researchers providing this as the best example. In this case, it's really unclear what's happening here, even though this kind of looks like a galaxy. But this is basically now referred to as the unknown object. But because this worked so well, this is of course just the beginning. The success of this model with the Hubble images essentially means that we can now apply very similar strategy to a lot of other big data projects involving other telescopes. And with ESA's Euclid mission now observing billions of galaxies, and even Vera Rubin Observatory collecting 50 petabytes of data that's going to become available very soon, models like this will allow researchers to discover even more anomalies, and to then potentially start answering questions about the universe that we could not tackle before. Because in some of these cases, it's actually unclear how these objects form, and what phenomena are responsible for these very strange shapes. But because even in this study researchers discovered some objects that essentially defied classification and that we cannot explain right now, or basically objects that are truly unknown, this is why these studies are so important, because here we finally might find some clues about new physics or unknown physics, because some of these objects seem to form shapes we could never imagine. And so even after 35 years of looking at the same pictures, there is still apparently so much more we haven't seen and so much more that was hiding from scientists this whole time. But we'll definitely come back and discuss this more once there are some updates, or once scientists discover something else, or I guess more importantly, once there are some explanations on what exactly some of these objects actually are. And until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.